So in my previous class, I talked about a puzzle, and that puzzle is known as instant insanity. Okay, so if you Google this instant insanity, in Google you will find the details about this puzzle. The main objective of this class would be to show how graph theory plays an important role in solving that puzzle. So what is the statement of that puzzle? In my last class, I have already explained through some example, but let me repeat once again. Suppose you are given with four cubes with a specific color. For example, suppose you are given with four cubes. So each of the cubes are colored with a specific pattern. For example, suppose this is the first cube, and this first cube is colored in that way. Let us try to explain what is the meaning, how it looks like. So suppose this is the cube and it has a specific coloring like this. So suppose this is the front, so I associate with this face. So this is a blue face. Okay, so this is the blue face, this is the front face, and suppose they are the remaining faces. For example, just left to it, it's the red. So this represents the left of this face, that means the left face of this. So this one is red, and this one, if you just wrap it up, it becomes here, that means this is the bottom face. So this is also red. So this is the right face of this. If you consider this as a front, then this is the right face. So this is green. And if you just fold it out here, that will come to the back of this blue face. So that means the back is white, the back part. So if this is the front, then back is white. And this is the top. If I just wrap it up, then that will be the top face. Top face is red. So is the mapping clear to all of you, how it's being represented here? Okay, let's test whether you understood it or not. So let's have a look at this again, maybe with Q4. Okay, I will ask one by one to describe. Suppose this is the front. That means suppose this is green. This is the front face. Okay, so this is the green face, front. Okay, now I want to represent this, the white one. So what would be the white one? So where the white color will be placed? So if this is front, this is left, this is top, this is right, this is bottom, and this one, this is back. So this is back, this is top. So if this is front, green is front, so left is this side, this is right, and this is the bottom one. Okay, now Pratik, can you tell me what would be the left color?
So white.
White, very good. So left is white. Swapnil, can you tell me what would be the top color? Swapnil, are you there? Okay,
Sir,
then yes, what would be the top color?
sir, it will be blue.
In cube 4.
S- Uh, sir, mm, one, sir, green.
No, green is on the front. So I am talking about cube 4. So this is the front, this is the left.
Oh,
Then
okay, 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 okay. One second. Red, 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 red,
yes,
red,
correct.
red, red. Sorry, sir.
Red. So Anubhav, can you tell me what would be the back?
No, sir.
No,
I
sir. What does it mean?
read these parts actually.
Okay, but try. So this is the front color. Okay, so just try to imagine, mathematicians can imagine anything. So it's a kind of packet that you are wrapping. I think you might have seen the packet for sweet packets. So when we have the packets for sweets, so usually it comes in a flat way, and then you have to fold it so that it looks like a rectangular or in a I mean in a proper shape. So just try to wrap it up. So this is the front, this is the left, this is the right, so this is the top, and this is the bottom. So which should go to the back if you just wrap it up?
So it should be green.
Very good. Okay, so it's green. And who else will tell me? Let's see what the people are there. Okay, Kolpok is there. So Kolpok, can you tell me what would be the bottom, the
Sir,
color of this bottom? Sorry.
blue.
Yes, exactly. And who will tell the right? Somebody volunteer yourself to tell
Blue,
me.
sir.
Blue. Great. Very good. So now you understand the packing system, or now, so it's nothing but a kind of mapping. So it's mapping so that any cube can be mapped with these colors so that I can have a visualization. So it's a mathematical way of writing, and this is the actually visualizing these things, because for mathematician you may not have the original cube at your hand, but you can draw it on the flat plane like this. So that's very good. So now you know that there are four cubes at our hand with specific colorings. That means it's not like arbitrary colored. So the first cube is colored in this fashion, second cube is colored in this fashion, third and fourth. So you have four cubes with a specific coloring on each face of that cube. Now the problem or the puzzle says that, so you have to stack one cube after another. So it's a kind of stacking of four cubes one after another. But the point is, so you can see that here, if you consider this as a whole stack, then so this is the front face. So here this is the left, this is the top, this is the bottom, this is the right, and there is another face which is the back, right? So you can see that there are six faces. If I stack four of this cubes one after another, then we can see six faces. Now discuss about this top and bottom face. Okay, so now we are left with four faces: front, back, left, right. Okay, the problem of the puzzle, it says that you have to place this particular four cubes. So you can interchange the first, second, third, and fourth. So there will be four factorial ways that you can arrange these four cubes. It doesn't matter, but the point is, if you stack these cubes one after another, then the cube should be like that. Each face. So suppose this is the front face. The front face should have four distinct colors. That means no color should repeat once. I mean more than once. That means it should have all the four colors. Similarly, if you consider the right face, the four colors should be present. Similarly, for the left face, it should also be the four colors. Similarly, to the back, all the four colors, four distinct colors should be present. That means in each of these faces, you cannot repeat any color. Okay, so that's the puzzle. Now, is the puzzle clear to all of you? So you can see that in this face, in the front face, we have red, white, green, and blue. At the same time, we have at the right face, we have blue, red, white, and green. So see that if you consider a particular face, then you can see that all the four colors appears exactly once. Here also all the four colors appears exactly once. So from this image, you cannot see the left face as well as the back face, but the same property should also appear in both the faces. So that's the point, and the question is how to solve this. One way you can start doing or visualizing things and try to rotate it, and you will get certainly one of the solutions. And the answer is okay, there are solutions, and once you do it by hand, you will understand that there could be many other solutions. One simple way, you can simply uh, give a permutation on the cubes that will give a different pattern, so that will give you a maybe a different solution. If you fix up a particular face, so if I fix this as a front face, then back face, left face and right face, so if you just give a permutation on the cubes, then you will get different solutions. So you can understand that there could be different solutions. Now the questions are how many solutions could be one questions, or how many maximum solutions that you could have one solution, or for the time being I am happy with at least one solution. Okay. And if you do it by hand, then only you will understand that it's not that easy. It's not that easy to get a solution of this particular problem, because unless you do it by hand, you won't be able to recognize the hardness of this problem. But once you do this, you will able to get at least some idea how to do that. Okay. But in this class, since this is for a graph theoretic class, so I will prefer to give a solution using a simple graph theoretic technique. So in my last class, I have already mentioned about the idea of graph, the idea of subgraph, the idea of edge disjoint subgraphs. That means two graphs or two subgraphs, we call them edge disjoint if they do not have any common edge. So if we have up to that much knowledge about graph theory, then we will able to solve this problem. Okay, let's have a solution of this problem step by step way. I have taken some photographs from Google and I am thankful to them. So let's have a solution, but here we have a little more, I mean, one different color. So here you can see that I have a green, yellow at the center. So the same thing, the three blue, three red here, one yellow, green and blue is there. So instead of in my previous slide, it was like white. So instead of white, I have yellow, and I have taken this photographs from Google. So I'm thankful to Google for giving us, or the person who made this. So I'm thankful to them, and I'm using their made ready-made images for my own purpose. So I'm thankful to them. So it's just a kind of acknowledgement to them. Okay. So just here the colors are little different, but the problem is exactly the same. Here we have red, yellow, green and blue. So four cubes, as I have already mentioned how to map these four cubes into this form. Now the question is how to solve this. The first step that we are going to do is, from each cube we are going to draw a graph. So the question is, how do I draw this? And to draw a graph, we should have some vertices and some edges. So the question is, what would be the vertex set and what would be the edge set, and how the edges will be connected with each other. So that's the first question. Okay, let me first try to explain the cube one. Okay, so what I do, I first take all the colors. So there are four colors, and I am just giving the four colors as four vertices. So here red is one vertex, yellow is another vertex, green is another vertex, and blue is another vertex. Okay. Now with this cube one, how do I draw this? So from here you can visualize the cube. Now if this is, say, one color, that means one vertex will be connected to another vertex if these two colors are opposite, are colored in the opposite face of the cube. For example, you can understand that for this red color, the opposite side of the opposite face of this face will be colored with green color. Okay, that's why red and green, there is an edge. Okay. Now similarly, if you consider here yellow, the back portion of it will be blue. That's why yellow and blue are colored with, are joined by an edge. Now you can see that this red and this red, so this will be at the bottom and this will be on the top. That's why they are in opposite color. That's why I have a loop from red to red. Okay. Similarly, I have from, okay, so now the first question is, if I draw this, how many edges should we have and how many vertices should we have? Quickly, can you explain a bit how many edges that we should have and how many vertices we should have? If I
So
draw
three,
like this, four vertices, it's clear because there are four colors. Now the question is, how many edges we should have?
three edges.
Three edges. Why?
So three pair of opposite.
Yes, because there are exactly six faces. So two faces will be joined by an edge. That's why there will be exactly three edges. So we are exhausted here. So this is one edge, this is one edge, this is one edge. So this is a loop here. Okay. Now can you just quickly draw this cube 2 and cube 3? So you can draw cube 2 and cube 3 because here yellow and the back side of yellow is green. So the back side of yellow is green. That's why it's here. And so this red and yellow, they are in the opposite side. Red and yellow are in the opposite side, and blue and red are in the opposite side. So blue and red are in the opposite side. So here this one this represents they are in the cube 1. So the naming of the edge is actually stands for, this edge is actually from which cube. So this is from 1, this is from 1, similarly they are for 2. So likewise we can draw the remaining edges for all of these cubes. Now what I am going to do is that you can see that we just superimpose all of them. So keeping the first, we keep the four vertices fixed. So red, blue, green and yellow. For example, red, blue, green and yellow, we keep it red, blue, green and yellow, keep it this fixed. Okay, so you can understand from here, if I want to this, so there should be one edge for this. This is 3. There will be, there is no other edge, so there is one edge from here. So I will have, this is for 4, and there is one edge from here. This is for 3, and there is a loop here for 3, and there is nothing. Okay, now I need to just map it here. So it's there is a loop on red, so I'll put it loop on red. There is an edge from yellow to blue. There is one edge from yellow to blue. That means that is a parallel one. This is one, and there is one from red to green. That means again a parallel edge. So this is for 1. Now you can see that this looks like this. So there are 2, 2, 3. So yes, already there. So this graph and this graph look similar. Did I miss any edge? Okay, there are 3 edge. Yes, I missed one. So this is also for 4, right? Yes. So this is 4. Yeah. Now I think yeah, there will be another. This is 2 to 4. Yes. Now I think it's complete, right? So now it's clear to you how I prepare these two graphs. I mean this graph. So I just combine all these three graphs to form a graph which looks like this, which actually includes all the four cubes, right? So all the four cubes are marked here and all the colors are there. So this is a kind of combination of all these graphs. Okay, now the question is, why do I require the graphs, and what is actually giving me a kind of hints how to draw the solution or how to get this solution. Okay, so let us try to take a kind of just fix up some direction here in the graph. So suppose I am giving a direction like from back to front this direction, and from left to right this direction. Okay, and say I take this subgraph, first subgraph like this. So this is my first subgraph of this. That means some part of it, you can see that I have taken from here this 3. So this is the 3, and I have taken the 2 from here. So this is my 2, and I have taken 1 from here, and all the 4 colors. So this is one subgraph A, and I have taken another subgraph. I have taken, say, with maybe different color. I have taken this edge. I have taken also this edge. I have taken this edge. Taken this. I have taken both. So they are two subgraphs, but I have given some arrows out of which. Okay, let's have a look why I am giving the colors and what is the reason that the color, how these colors will give me the, or the direction or the vertices will give me the answer. Okay, so first let have a look at this. So these two subgraphs I have taken. First of all, what is basically we are trying to solve? So we are basically trying to have a stack of this kind of stack of this kind of squares, right? So that is our main aim. So we are basically trying to stack. So if we are going to stack this, so we are just kind of fixing something. For example, I call this as, say, front. I called this as a back. So front to back means, so this is white, and whatever be the color, if I have, say red, so if we have a black color at the, say if this is red, say blue is at the back. Okay, so the arrow should be from back to front. So if white is in the front and black is at the back, then my blue goes to white. So this is my notation, right? So because this is from back to front, so if this is front is white and black blue is at the back, then this should be blue to white. Okay, so that is the notation. Similarly, if we have this is for left and this is for right, I have left to right. Suppose this is my red and this is my blue, then I will have red to right. Sorry, red to blue with this direction. Okay, so what we need is basically two of these faces. For example, front and back, and the colors that should be represented by one subgraph. For example, suppose I have this. So this will represent the four faces, sorry, the two faces, say back and front. And these colors represent that. Suppose this is this to this, that means I have the back color is blue and the front color is red. This one means from red to, that means the back color is red and the front color is yellow. Similarly, the back color is red and the front color is green, and so on. So that's what I want to mean. That means two subgraphs means I basically covered four faces: front, back, left and right. So two subgraphs will actually help me to cover two faces. Now what is our idea? Our idea is to basically cover all the colors. That means you can understand that in each of these subgraphs there should be all the four colors should be present. Like you cannot consider three of the vertices, say red, blue and green. You cannot drop one of the vertices, because if you are going to drop one vertex, then the reflection of the fourth color you won't get. So I need a subgraph which should consist of all the four colors. So that is my first condition. Now So there will be many subgraphs which will contain all the four colors. So here A and B are the two subgraphs which contains all the colors with few edges. Now let us try to see any subgraph with all the four vertices will be sufficient for us or not. Okay, so that's the idea. So let us first check with this. So here we have this subgraph, and you can see that. So arrow from here to here means, say from here to here means the front is yellow, back is red, right? Because my direction is from back to front. So this arrow is represented through this, and since here 1 is placed here, that means I may increase a bit, then it would be easier for you to see. Since, okay, here I think, yes. Since this is 1 here, so that means this is for cube 1. So this is for cube 1, and red to green. That means back is red, front is green. So front is green, back is red. Now if I consider this, then the front is yellow and the back is red. Front is yellow, back is red. So you can see that I have already stacked 4 of the cubes, 1, 2, 3, 4, among which one front face represents green and this represents black. So this is a valid way of putting it, because I am just putting the first cube. But while I am putting the second cube, you can see that it is cube 1, cube 2 is yellow, but the back face is red. So you can understand that this you cannot allow, because you are actually repeating the two colors. Okay, not only that, see here, for there is no edge labeled with 4. So I have 1, I have 2, I have 3. That means I have no label on edge on 4. That means the existence of fourth cube, I don't have any information from this subgraph. So that means I cannot write any color here, because from this subgraph I do not have any information about that color, about that cube. So from here, what would be your conclusion? Can you please explain what would be your conclusion from here? Till now, if I consider A to be a subgraph, then we find that few lackings are there. First of all, here you can see that two reds are appearing. Not only that, here the one cube information is missing. Now, can you tell me? So the first point is I should have all the 4 points, all the 4 colors, right? First point should be my subgraph should contain all the 4 colors, right? So this is my first point. And can you tell me any extra point, somebody? What should be the properties of the subgraph? Anybody, can somebody tell me?
So can you please repeat the question?
Yes. So till now you understand that I am actually considering one subgraph A, okay, to solve this problem. So the idea is I am going to consider two subgraphs. So one subgraph will represent the stacking of 4 cubes, and that will represent the front and back view. So what should be the color distribution of the 4 cubes only for front and back portion. And another subgraph should represent the same thing but for the left and right view. That means what should be on the left face and what should be on the right face. It gives me the idea what should be from the front face and what should be from the back face of that whole thing. So I have a kind of all the cubes are stacked here. So I need basically, so if I consider this is as the front, this is at the right, this is at the left, and there is the back portion of this. So this is at the back, okay, which is just opposite to the front. So this subgraph should represent me the distribution of colors. For example, say this is cube 1. So this is cube 1 and this represents me. So this should be, so this means one arrow is from red to green. That means the front is green and the back is red. That means front is green and the back portion just opposite is the red. For cube 2, it gives me it is yellow and the back is red. But as I mentioned, this is not a valid coloring because in the back portion you are repeating this color. For the third cube, it gives me information that the front should be red and the back should be blue. That is valid. But this subgraph gives me no information about the fourth cube. Okay. So that means this subgraph will not be helpful for me. So first property that I understand from here is that the subgraph that we are going to consider must contain all the four colors, because if you are having only, say if you are not having yellow in this field in this subgraph, then you will not get any information where the yellow color should be placed. That means you must have all the four colors. So that is one property. Then I want some extra property. What should be? Now is the question clear? What should be some extra property on the edges?
Say it must on a of all numbers must be there is 1, 2,
Yes,
and 4.
1, 2, 3, and 4 must always be there in the graph to get the solution of this. Because if you are missing with some of the edge having some number, for example, the edges with number 4 is missing here, as a result you cannot fill up this row because you don't know which color you should place here because there is no information from that graph. That means you must have all the four edges. Now we consider, suppose this is a subgraph. So in this subgraph I have all the four edges, I mean all the edges with the four numberings 1 2 3 4, as well as we have all the four colors. Now will this be sufficient? What is your view? Is if I consider this graph, then will that be sufficient for you? Okay, let's have a look at this one. Say 2 3, and so there is one. So that means it's from left to right, right? So that means in a left you have red, on the right you have blue, and this arrow will stands for, so this is for cube, so this is for say cube, so one cube, say cube 2. So this is left and this is right. Okay, this is left, this is right, and this is for cube 2. So for cube 2, if you consider from cube 2, for this arrow I should have red here and I should have blue here. Okay, and for this is for cube 3. So for cube 3, the same thing will happen like this. For cube 3, the left is blue and the right is green, sorry, right is red. Okay, now you understand. Now tell me whether this is a valid subgraph that will be helpful in solving our problem, whether that is a valid one or not. What
So
is your
there,
view?
so there is an ambiguity in the information because there are two edges, number 2. So it once it says that there is red on left in the second cube, there is left red on the left side and blue on right, and again it says there is uh, yellow on the right and green on the left. So we
Oh,
don't know which is correct.
Sir, the
exactly.
same problem happens for cube 1 too. There is a different statements there.
Where in?
For cube 1, sir.
Yes, exactly. Now this is clear to you, right? For this, yeah, I think it's too big. Yes. Now from 2, if you write like this, for cube 1, you also have the ambiguity. Once it says that in the left you should have a yellow, again it says that from another edge, it says that on the left it should be red. So there will be an ambiguity. Now tell me why this ambiguity came. What is the reason that this ambiguity came?
The repetition of a age of same number.
Okay, so that means you must have all the edges with the numbers. That means all the different number edges will appear exactly once. So you cannot repeat the edge number more than once, and it should appear exactly once, right? Is it okay to
Yes.
repeat? You cannot repeat the edge. Is it clear to all of you? Any ambiguity if you have, please tell me. Okay, so I think it's clear to all of you. So till now, I have two properties, like we should have, okay, let's see. Yes, we should have, so both subgraphs contain all the four vertices. This is property number 1, and the conditions 2 says that the edges of each subgraph are labeled by all four numbers 1, 2, 3, 4 exactly once. That is very important. Now, are you getting some idea what I'm actually trying to do? What is, how should I get this solution? And why we are considering two subgraphs, and these two subgraphs should look like what should be the more properties, and how these two subgraphs will give me the actual solution. What is the justification? Any now, till now, whatever I told you, any guess, any hints that you are having? Any idea? Why there's two subgraphs? Is it now? Yes.
All the vertices should always have at least two edges. This will be also important.
Sorry.
And
Could you please repeat once again?
all the vertices
Yes.
should have exactly two edges. If not, then if one vertex has one edge, then it will only appear once. Then one place is empty. It will always be empty as we have four colors and four places to fill.
Okay. Yes, but is it clear why these two subgraphs are required? Say why this A and B are required. So our basic aim is to, from A, I will have the view of front and back. At the same time, with another subgraph, I should have the view from left to right. Okay. So if I have these two subgraphs with me, then I need to place them in such a way that one should depend on another, or there must be some connection between A and B in such a way that the color distribution that is given by A should give me front and back. At the same time, the color distribution from the for B, that should give me from left to right. So that is the basic idea of mine. So now, as told, as he mentioned that there must be from each vertex. So I need to have all the four vertices, and each vertex must have exactly two. Each of these subgraphs should be like this. Each vertex should have exactly two edges. So you cannot have, you if you are going to see, there will be four numbers exactly once, means it should appear exactly once. Now how many ways or how you can place them? So there will be like this. You cannot leave any of the vertex, like, so there are four vertices and four edges. Now how to join them? If you are going to join them like this, so there are two edges, there are two edges like this, then you can understand that, suppose I have given 1, 2, 3, 4. and these four vertices are there, say red, green, blue, yellow. Then what would be the problem here? Can somebody explain me? If the graph is like this, what would be the problem? So I have all the four colors, I have all the vertices, I have all the numbered edges with 1, 2, 3, 4. And suppose I draw another, okay, suppose I draw this. So what would be the problem here? Any problem that you find it now?
Sir, there will be repetitions of colors.
How?
Sir, this is no, one. This is front to back.
So this is, suppose this is front to back, okay, front to back. So place some direction here.
Yes,
Okay, so which direction you want to put? Tell me.
from R to G.
Say from R to G.
No, no, no. Sir, sorry. This is one subgraph is back to front, the A, and B is left to right. So
Yes, so I'm just
um,
say this is my A. If my subgraph is like this, then will that be any problem here?
Sir, we are already given some configuration. So can we use any configuration of our own, because we are restricted by the configuration of the cube that we are given. So
Yes,
if we place the directions by our own wish, so that will
yes.
violate the configuration.
That may violate the
Yes, sir.
configuration. Yes. So you cannot give any arbitrary direction. So what you need to do, you have to take some subgraphs from this original graph. So if you take any or some subgraphs from the original graph, then it's fine. That then it won't violate. So this is your original graph. Where is your? This is your original graph. If you take any subgraph of this, then that won't violate. But you see that I have taken the subgraph here. So what I am taken here, it's my red. This is my blue. This is my green, and this is my yellow. And I have just taken this two. So this is very much a subgraph of this original graph. So the question is whether that will be a problem or not. Whether till now, whatever we thought, is it a valid coloring or it's a valid subgraph? Say if I consider this to be A, then some direction I need to fix. So this is say for front to back, or it was mentioned here back to front. Okay, so from back to front. So will there be any problem till now? So the first question is, shall we only consider A or shall we consider always A and B simultaneously? So till now, is it clear to you that you require two subgraphs A and B? Okay. So if I consider A to be like this, then what would be my B? At the same time, I should consider it because both A and B will ultimately give me the solution. If A and B is like this, whether uh, what would be my B? So can this be, so here this is so this is 2, this is 3, this is 2, this is 4. Now you see that it is not a valid one because not all the edges, all the edge numbers, so one is missing here. So the second condition that I have already mentioned, you cannot draw this because here 2 is repeating. So I must take at least one edge that should have be numbered with 1. So I cannot take two here's. So that is the problem. So I cannot take this as a subgraph. Okay. So so the question is, then what should be the other conditions? What should be my other condition? Okay. Let's have a look at this subgraph. So suppose I consider this subgraph, and here you can see that 1 is here, 2 is here, 3 is here, 4 is also here, and all the 4 colors are also present. Now the question is, will that give me the required subgraph for my purpose? If you draw like this, then you can see that it's basically repeating these two colors. And why this is so? Because the direction here, see from, so this will be your front and this is your back. These two directions are basically the same from the same vertex. Okay, so this is also very important, because see, two of these conditions are being satisfied with this subgraph, but still you can say that if I draw like this, then this will not be a valid one, because here we have the difficulties. Here these two colors are actually appearing twice, but that should not be the case. Here also we have, in the front we have these two colors same. See why this is coming so? Because this is incident to this, so this direction of this arrow plays an important role. For this means, if I put an arrow towards this vertex, that means that will be my front for cube 2, and this arrow for cube 1 means that will be my front for cube 1. That's why these two colors become the same. That means you cannot take any arbitrary arrow of this subgraph. So you also have to keep in your mind so that the arrows should have in a proper place. Now can you tell me what could be the arrow condition? So till now it's clear that all the 4 colors should be there. Till now we all check that all the edge numbers should appear exactly once. Now it's a time for arrow, because all these two properties are being satisfied here, but the arrows are making some differences. So what will be your condition now? This condition 3 plays an important role. It says that each vertex is incident to one edge directed in and one edge directed out. So you cannot have, if you have something like this, there should be some arrow going out. Otherwise, if you have both of them directed in, that means the end vertex or the back vertex should be this. So if we have one vertex, then you cannot have the direction on that vertex. That means you cannot have the incidence. So this is means this edge is incident on this vertex. So this direction means this edge is incident on this vertex, and if you have the direction in this way, that means this edge is also incident on this vertex, and if this is from front to back or back to front, that means both of them, they will have the same color on a same face, and that should not be the case. That's why each vertex is incident to one edge directed in and one edge directed out. That means here both the directions are in the same direction, but it should be like one coming in and one coming out. So this is one very important factor. Is this point clear to all of you? Okay. Now I need to check one more thing. So till now we talked about only one subgraph. As I mentioned, I require two subgraphs simultaneously. It's not like one does not depend on other. So one very much depends on other. Now if you find that you take two of the subgraphs, but they have a common edge with a common direction. For example, say A is a subgraph, B is a subgraph, and this edge is common in both of them, then what would be the problem? You can see that the problem would be, what would be the problem if both of them will have the same direction, same common edge? What would be your problem? Can you tell me what would be your problem?
Sir, we will lose two colors in a single cube because we will have two colors in a specific cube in opposite faces.
Yes, then what would be the problem?
Sir, it will eventually repeat for other cube or violate the cube's own color.
So the cubes that are given have only one color of more than one multiplicity. Now it will have two colors of more than one multiplicity
It says two colors.
with more
Yes,
than one repetition. But the cubes given have only one repetition color.
yes. So that's what it's required. We need to go back to the original one. So here you can see that if you have, so that means if you take this one, if you take this one, red and green, that means in cube 1 you should have two green and two red, but you have only one green here, so you cannot afford two greens. Two reds are fine, but you cannot have two greens on cube 1. So due to the fact that the distribution of colors on the faces of the cubes are fixed, you cannot arbitrarily assign the colors. That's very important. So the graph should have no edge in common. If you have in common, then there will be, due to this distribution of the colors, you can see that here there are two greens, two blues, but not always you will have the freedom to choose all the colors. So keeping in all these minds, finally, can you give me one solution? So now you have this graph at your hand. So let me find whether you have some better. Okay, so now you can see this subgraph. I will make it in the zoom. Yes, from here, can you give me one solution? So maybe, yes. So this is my two subgraphs. I require two subgraphs from where you need to give me the solution, keeping in mind all the four properties. Very quickly, can somebody give me one solution for that? It will take some time maybe. Now is it clear to you what subgraph? So the idea is two subgraphs should be edge disjoint. You cannot have the same edge in two subgraphs, because if you have two subgraphs, then that may cause a problem of repeating the colors that you don't have, the colors you don't have, but it will certainly repeat the color. So it has to be kind of edge disjoint subgraphs. So please try to solve this and try to get to disjoint, edge disjoint. That means there should not be any edge in common.
So,
Yes.
so if we start from the red vertex, the one.
Okay, just a minute. I'll draw it here. Yes, tell me from red.
Red from red three to three path, three edge.
Okay, just a minute. I'll just make it. make it yellow. Yes. Now tell me from
Red to blue, age 3.
red to blue, age 3. Okay.
So, from blue to yellow through 1,
Blue to yellow, 1.
and yellow to green through 2,
Yellow to green, 2.
and from green to red through 4.
So 4. Okay. This is my A. And what would be my B? Just a minute again. Yes.
So from red to blue through 2,
2.
blue to yellow through 3,
Blue to yellow, 3.
from yellow to green through 4, 1.
So see, they are edge disjoint. Why they are edge disjoint? Because here this is 3. Here I am using 2. It's 1 and 3. It's 4 and 2, and it's 1 and 4. So all the properties are satisfied. Now let us take how the solution looks like in a in this cube. So let me try to draw these cubes now. So two disjoint subgraphs are there, A and B. Now from here, so this is from say write it like front to back, so that will be easier for us. So if just opposite direction as mentioned till now, so this is from red to blue, means front is red, back is blue, just the opposite of the things that I have till now told about you. But now for the sake of simplicity, I am taking is from front to back, means from red to blue. Okay. Now if I consider like this, then can you tell me the faces for cube 1? So they are the, so this is for front and back view. So from A I will get this. So what would be my front and back view? So what is front? Pratik, can you tell me what is in the front? In, so this is say cube 1. Say this is 1, cube 2, cube 3, cube 4. Okay. So in cube 1, what would be my front face?
So blue.
Okay, so front is blue. For cube 2,
So yellow.
yellow. Cube 3,
So red.
red. And cube 4, green.
So green.
Okay. Now what is there in the, say, right side of it? So that will come from, so once this is done, then I can always have the back. So the, this is the for the back, right? So I'll just put it for the back. Okay, tell me from A, what are the on the back? So if it is blue, then what is at the back?
So yellow.
Yellow. Then for yellow, what is at the back? What is at the back for cube 2?
Greens.
Green. For red, what is
Blue.
at the back? Blue. And for
Red.
this is red. Okay. Now tell me from B. So this is my B. From B, what should be on the right and what should be on the left? So for cube 1, right is
So red.
red and left is, so this is left. Left is
Greens.
green. Okay, green. Okay, then
For
for
two,
cube 2,
so cube two left is red.
cube 2 left is red and
The right is blue.
right is blue. For cube 3,
So left is blue, right is yellow.
yellow, and this is
Yellow
yellow,
and
green. Now you can see all the faces. For example, if I consider cube 1, then you can see that in cube 1 you have how many, uh, so one green, one blue, one red, one yellow. Okay, so that is eligible. But you can see in this, in red, blue, green, yellow, yellow, green, green, so it is the only place where you have two greens repeating on the same cube, but that is eligible because they are not in the same face. So this face and this face, so what you need to check whether all the columns should have a distinct values. So yellow, green, so yellow, green, red and blue. So this is one solution. Can anybody tell me another solution from two subgraphs of it, like A and B? Can anybody tell me any other solution?
Sir,
Yes.
for all the for graph A and B, if you just invert the direction, then we can also get another solution. If you invert all the direction for each edge.
So, okay, if you invert a direction like a symmetric way, maybe that would be a kind of rotation of columns, maybe. You need to check how geometrically that will represent, right? So,
so
suppose
the
you,
how will
you,
be rotated.
yeah, I think in a symmetric, in a systematic way, then maybe rotation of the uh, rotation of this cube, I mean the stacked cubes, maybe the same thing will the similar effect if you just change the direction of this, because you are changing from left to right, right to left, and maybe uh, left to right and right to left in a symmetric way. If you do this, then yes, that would be also be a solution. Very good. But what I want, I need some other subgraphs as a basic level. Any other subgraph? Okay, but I think, is the problem clear to all of you? And how this graph theory, just a very simple idea of how two disjoint, I mean edge disjoint subgraphs are giving me the solution for that particular problem, which is apparently not that easy if you do it by hand. And if we exhaust all possible solutions, then you can see that that would be a quite a big number. For computers also, it will take some time to solve this problem. But using graph theoretic technique, you will surely have one solution, and that's quite interesting. So is the problem clear to all of you? Is the solution clear to all of you? Any question or any doubts if you have, please share me.